Hello, my name is Corbin Irwin, and this is a presentation for CYB 690, Cybersecurity Program Development at Grand Canyon University. Today we're going to be talking about Root Out IT Solutions, a tech company that provides IT solutions for healthcare providers. We've got several objectives today when we're discussing our company. First, we're going to be examining the current cybersecurity environment. We're going to explain the risk management practices. We're going to examine the cybersecurity program development in regards to frameworks. And we're going to examine driving factors within workflow and decision making. We're going to examine critical components for compliance with regulations, and we're going to discuss the elements of the software assurance maturity model. So let's talk about the current cybersecurity environment here at Root Out IT. I'm going to read really quick a current state report, and then we're going to talk about several of the different components. Security is the utmost importance here at Root Out IT, and as an organization, we have focused on creating processes that protect our networks, data, and information systems, as well as those of our clients. The current cybersecurity environment is based on the implementation of the NIST, National Institute for Standards and Technology framework. Risk assessment and threat development are based on the cybersecurity lifecycle and strive to address emerging concerns and threats. So let's talk a little bit about the paradigms we use, or some of the factors that really drive what we're doing. We've shifted towards zero trust. The zero trust paradigm approaches security from the perspective that all users, applications, devices, connections are threats and shouldn't be trusted. So essentially, we don't trust anything. That is where we're starting. So that allows us to approach everything as a security concern and root all of our decision making with security. Cloud first is something that we're seeing a lot. So more and more companies are seeking cloud services over traditional solutions for their IT and security needs. And because we deal with a lot of different clientele in the healthcare industry, we want to make sure that we're dedicated to providing cloud solutions that put security first. So those are the two paradigms that we are using currently to really shape our current cybersecurity environment. In information management, information security is enforced using strict access control, data classifications, data encryptions at all states, so in transit, rest, and use, and we use data loss prevention systems as well. And we also do data auditing. So that's how we take care of data or information management currently. Configuration management, we manage all system configurations, base configurations, patches and updates, and configuration change management as critical parts of our overall configuration management program. We do this to maintain secure configurations, and we think it's a crucial part of our zero trust environment. So essentially what we can get from that is that we are managing all of our default systems, we're managing all of the default settings, we're managing systems completely so that there is no room for error, and that they really are operating under a zero trust environment. So what systems do we actually use for security currently within our environment? Well, we're using several different systems such as a firewall, including next generation firewall, application level firewalls, intrusion detection and prevention systems, identity and access management systems, security information and event management systems, or SIEMs, endpoint detection tools, antivirus software, load balancers, and secure VPN connections. So when we take all these different components, such as the paradigms that are driving us, our information management, configuration management, security solutions, we're able to address some of the different business risks that we're seeing. So our current business/risk management status is what we want to talk about next. Now, this is information that we borrowed from our business profile, which gives a brief recap of everything that we have going on here at Root Out IT Solutions. And we've added in some information about regulatory and risk management theory. So let's talk about that a little bit. So Root Out IT Solutions is our company name. Our mission is to empower both clients and employees by putting people first and providing the best in-class services and tools to ensure safety and functionality within the ever-changing landscape of health information technology. Our vision is to provide impactful IT solutions to every client. We have different goals, such as expanding our market share, recruiting clientele, providing world-class customer service, and retaining long-term clients, and to provide quality and contemporary IT and cybersecurity solutions for our clients. We also want to provide regulatory compliant IT and security solutions that meet customers' needs. So what regulatory requirements are we typically talking about? Typically with healthcare clients and ourselves, we're looking at HITECH, HIPAA, PCI DSS, and the NIST framework. And those are what we're basing a lot of our decision making on. So when we're using those, we also need to consider risk management and threat development. With that in mind, we use risk assessment following the NIST framework core and cybersecurity lifecycle. We're going to talk about that more in a little bit here. So organizational constraints, things that we have to consider when we're actually making our cybersecurity program are cost, resources, use of legacy systems, often our clients have older systems, and software, legacy software rather. So that all leads us to business alignment with the NAST framework. Here we can see several of the different factors within the NAST lifecycle and core functions. The core functions are identify, protect, detect, respond, and recover. Within identify, we're looking at threats, assets, and tools that we currently have to help us or deter us from information safety. So we need to consider all of those different factors. Some of the examples here are patient portal and API, servers and outward-facing services, electronic health record systems, company and workstations, and different assets. We can also see risk assessments that tell us about the risks that we are currently facing. And we also have in here staff resources, our cybersecurity policy, so tools that we can use. So then we're thinking about how we can protect our assets. Well, we can do staff awareness and training, for example. We can utilize encryption for data on all states. That's something that meets HIPAA, high-tech compliant, as well as PCI DSS. So these are all things that we need to consider. And as we can see, the factors from before have helped shape what is actually on the sheet, because we're moving toward compliance. We're utilizing firewalls, another compliance thing, with intrusion prevention system to block attackers. Within detect, we have intrusion detection systems. We have regular auditing of logs, another compliance factor. And then in respond, we have maintaining an incident response plan, another compliance factor. Methods of communication outlined for employees and stakeholders, that's also a compliance factor. As you can see, all of these compliance factors with regulatory requirements really move into how we're actually doing our day-to-day operations. Within recovery, we have our disaster recovery plan, a business continuity plan so that we can keep going with critical business operation. And we have legal and PR teams for notifications, which is, again, a regulatory compliance factor. So all of these things work together to help us meet the expectations for what we were talking about earlier. So why do we use a framework or best practices when we're actually meeting these regulatory needs? Well, a framework allows us for the assessment of our current security measures and identifies needs and gaps. So it gives us somewhere to start when we're actually measuring how our program is doing. It provides guidance in clear terms for how security should be approached and what security measures should be implemented. So it gives us really clear direction. It allows us to create a program or update a program. It allows companies to assess risk, identify assets, establish needs, and set goals. As we can see previously, we used that in our identify section. It makes reaching compliance regulatory standards easier. It gives us a framework to build onto to meet those compliances, so it's much easier than just doing it without a system. It provides a systematic approach to program creation, maintenance, and execution, and provides guidance that may extend beyond immediate staff expertise or experience. So in our case, we have a lot of expertise and we have a lot of staff members who are very knowledgeable, but if there are education or knowledge gaps, this approach can allow those to be built upon by giving information and a framework to start with, so it can be really beneficial in that case as well. So we've talked about where we're at currently with our program. We've talked about how we're building on the NAST framework, and we've talked about the benefits of doing that. But let's talk a little bit about the decision-making workflow for Root-Out IT Solutions. Now, we have a very good diagram here that shows how information moves, and as you can see here, if you look at our pointer, it's a cyclical type movement. Now, information does move beyond all of the levels back and forth, but it also recycles back and forth because it's a similar setup to the life cycle where we're going to repeat things. Let's start with kind of the executive strategy level or the strategic level. The executive team is responsible for developing the overall cybersecurity strategy for the cybersecurity program. The strategic level considers business needs, resources, program and business objectives, and risk management. The strategic level communicates downward to the management tactical level. So let's move downward. So at the management tactical level, the management team implements security measures and manages the program's daily security operations. This team takes guidance from the strategic plan and creates workflow and processes. The management tactical team communicates downward to the operational staff with tasking and objectives. So they're taking this, moving into tasks, and communicating downward. Now, the management team also communicates upward to the executive team, informing them of threats, risk, and other concerns, which can then be implemented into the strategic plan. So let's go to the staff operational level. The staff is responsible for acting upon security tasks created by the management team. The staff will be tasked based on the strategic plan from the executive level. As staff members complete tasking, identified concerns will be communicated upward to the management and executive levels. The cyclical communication ensures that all information and decision making is shared between every level and can be acted upon appropriately. Now, some decisions can be made at each of these levels. There is autonomous power to make those decisions, but typically this is the workflow that we will see within our current program. So we looked at a lot of the measures that we have within the NIST framework in our last couple slides, but we want to talk about the critical cybersecurity needs to ensure compliance with regulation that we have here at Rootout IT. So risk assessment and management, we need to identify risks, threats, and assets and manage them through mitigation efforts. That's part of being compliant with HIPAA, with HITECH, with PCS, DSS, and with a lot of other regulatory standards at the state, national, and international levels. It's also part of the NIST framework. The cybersecurity policy and procedures, a comprehensive guide that helps steer the cybersecurity program as well as employee behaviors. We need to have that in place so that instructions are clear. Training and awareness programs ensure that employees are aware of risks and trained on how to protect the company and client assets. Having a rigorous training program helps us meet compliance in other areas, but isn't a compliance factor itself. The BCP, Business Continuity Plan, the IRP, Incident Response Plan, and the IRT, Incident Response Team, are all essential parts of regulatory compliance with HIPAA. It allows a company to continue critical business function, restore systems and information, and minimize the impact of an incident. That's what those guys do. The Cybersecurity Program Assessment and Auditing systematically examines the security measures and ensure regulatory and standard compliance. We have to have that across the board. We need to be looking to make sure that our measures are working, they're effective, and that they're meeting standards. And then security program testing, actively testing security measures to assess if they are effective. Data security measures. We need to ensure that data is stored securely, used and transmitted, ensuring that data has the highest level of availability and integrity. So we're talking about encryption there. As we saw in our last slide, we're encrypting at all states, and we're also making sure that it is high integrity data by doing data auditing, making sure that it's usable and available so our systems have backups and that they have a high availability. And then physical security, that's an important measure too. We implement physical security to meet regulatory compliance, and we minimize our attack surface. We're doing this with smart card IDs, locked doors, locked server racks, and things like that. But they're important parts of our cybersecurity program. So let's talk a little bit about Rootout IT's efforts, business needs, and outcomes. So organizational efforts, what we're moving toward. We want to implement and comply with upcoming releases of the NIST framework 2.0. So the cybersecurity framework is being updated. There is a current draft out. We want to make sure that we are moving toward compliance. We're aware of what's going to be coming out, and once it's updated officially, we are able to move toward compliance with that. Again, as we talked about earlier, we're moving toward a zero trust environment to increase our security. Business needs. We need to have secure systems that meet compliance for HIPAA, HITECH, PCI, DSS, and we need high reliable cloud-based solutions to market to clients. So those are our business needs. What outcomes are we expecting? We want to see increased client numbers for IT services, regulatory compliant networks, software, information systems, and cloud-based architecture, and want highly effective cybersecurity policy that meets current needs and can adapt quickly to emerging threats and risk. It's an ever-moving cybersecurity world, and we want to make sure that we are prepared for that. So the last thing we want to talk about is the Software Maturity Model, or SAM v2. SAM, Software Assurance Maturity Model, is a framework developed by OWASP that allows organizations to implement security measures during developmental stages. SAM gives organizations guidance for assessing their security within the developmental processes, and the model is designed so that it can be easily applied to any development method, and does not directly dictate the steps of the model, and allows organizations a larger view of security within the overall developmental process, and provides guidance on how to improve it. So essentially, it allows you to implement security controls no matter how you're developing your software, and gives you a framework that you can build on and customize to your needs. And that's very important when we're developing software for a client, because it's not always going to be the same process for everything we develop. So let's actually talk about the elements of SAM, or the Software Maturity Model. There's 5 core areas. So we have governance, design, implementation, verification, and operations. Now, let's talk about some of the subtopics as well, because they're very important. Under governance, we have metrics, strategy, improvements, creation, and promotion. So we're really measurable things that we can implement. What is our strategy for developing this program, and how are we implementing security? Then we have policy, standards, and compliance. How are we meeting compliance regulation while we're developing the software? What policies are in place to protect that? And then we have how we're actually disseminating that information, training and education, culture and awareness campaigns. Under design, we're going to look at threat assessment during design, threat modeling. How are we developing our threats, our ideas of threats? What do we know about the threats that we possibly could face? We have security requirements that vendors, software, and hardware might have, and we need to know those as well. And then how are we securing the architecture for our development? Then we're going to actually implement some measures. We're going to secure building processes. So as we're actually building things, we're going to make sure they're secure. We're going to implement security. The build process creation, software dependency, regulations, all that we're going to secure. We're going to have secure deployment processes. So as we're actually disseminating our software, we're going to make sure it's secure and that it's not being intercepted and modified. We're going to make sure there's high data integrity. So management of confidential information and secrets is also important, because there's things we aren't going to let people know when we're selling them the software. And the back end might be secret or not open source, of course. So we need to make sure that we're maintaining that secrecy. We're going to manage defects too. So if there's issues with our software, how are we managing those? How are we tracking them? And how are we getting feedback so we can fix issues that might come up and make sure they're not taken advantage of before we can address that? And then we have verification, architecture validation, assessment, and compliance. So how are we actually complying and making sure that we are following the architecture that we created earlier in governance? Control verification and abuse testing, making sure that our controls are effective. Security testing with scalability and well-developed security and software knowledge. Do we know what we're working with? We had it designed in our earlier steps, but do we actually know it? And are we able to scale the things that we're doing? Can we apply this to a bigger picture? Then operations, management of incidents, including incident response planning, incident detection steps, so making sure we have teams in place and measures. Control security environments, hardening steps and management, patch updating policies and procedures. So a lot of your typical IT controls here, or your cybersecurity controls rather. We got to make sure that we have hardening efforts in place. We have to make sure that we have policies for patching and updating. That's very important. And then management of operations, data protection measures, and legacy software elements. We need to make sure that we're managing all of the different components, such as legacy elements, what protection measures are in place, and data protection, encryption. For example, if we're developing software and we're transmitting it back and forth, do we have that software encrypted? Could it be intercepted? Could someone get access to the source code? Those are important factors to consider. Thank you so much for joining me today as we looked a little bit at Rootout IT Solutions cybersecurity program, its software development model, and all of the different factors that we implement to really meet regulatory compliance and keep our clients and our assets safe. Here are the references that we used today and some of the information that we were able to share with you. I hope you have a wonderful day. Looking forward to hearing from you soon.